The broadcast is now starting. All attendees are in listen-only mode.
Good morning, good afternoon, good evening, folks. Thank you for joining us for another episode of our Best Practices webinar series with 7Signal. If you'd like to, please let us know where you're tuning in from today. I know a few of you are already on the line before we began, which is why we got started early. I am back in the office in Cleveland today, and we are joined yet again by Jim Vada in Cincinnati. How are you today, Jim?
I'm good, Kelsey. The sun is shining and it's headed for 70 degrees Fahrenheit, so I'm happy.
Awesome. Well, that's great to hear. I see a few of you dropping in where you're joining us from. I see, let's see here, Claire from Pittsburgh. We have Per from Copenhagen, Denmark. Welcome back. We have Jeff joining us from Jacksonville, Florida. Let's see who else we have here. We have Germund, our special guest from last week, joining us from Norway again. Welcome back. And we have Wayne joining us from Denver. Thank you to all of you for dropping those in the chat panel. Please keep letting us know and we'll circle back with you later at the webinar. So we will go ahead and get started here. So we are 7Signal, the leader in wireless experience monitoring, and we'll go a little bit more into depth as to what that means, what that entails, and what our mission is at 7Signal. So we have a great topic here today, deep dive into DFS Part 2. I believe, Jim, correct me if I'm wrong, the first time we dove into this topic was, I think, in July. Is that right?
Yeah, that's right.
Awesome.
So we'll do a little bit of a refresher on some of the same content, and also I'll touch on what's going to happen in 6 gigahertz with the AFC system there.
Perfect. Sounds very exciting there. So just a little introduction. I'm Kelsey Rizzuto, the marketing specialist here at 7Signal. And of course, as we mentioned, we have Jim Vada here today for our guest, CWNE number 183 and Director of Global Wi-Fi Solutions here at 7Signal. So let's go ahead and dive into this topic here today. Before we start, a few announcements for those of you who have recently joined us. These will sound familiar, but we do partner with CWNP for every single one of our webinars. So by watching these webinars, you are eligible for CE credits. If you're pursuing a certification, just drop us a message and we can send you over a certificate per request. We also do a product tour every single Friday at 12 noon Eastern at that link, go.7signal.com/tour, where you can register. And we'll go ahead and drop that link in the chat here if you care to check it out. But we don't go too into depth with product or any kind of demo on these Wednesday webinars, but we will give you a few exciting announcements here for some product updates. We announced a few weeks ago the release of Mobileye for iGel Linux. We also recently added enhancements to Sapphire Eye over-the-air mode. And this past month, we announced the release of a portable Sapphire Eye sensor. So a lot of exciting updates there. If you haven't recently joined a product tour on a Friday, maybe care to do so just because of these updates here, and we will go ahead and keep moving forward. We also post all of our archived webinars to our YouTube channel. So today's broadcast will be up there later this afternoon. So you can go ahead and check that out and some of our previous webinars as well. We also post all of our slides to our Twitter account at 7Signal, so go ahead and give us a follow. But if you still want access to the slides and you aren't on Twitter, that's no problem. Just drop us a message, shoot us an email, and we can send those over per request as well. Another great reason to follow us on Twitter is because we give away a lot of 7Signal merchandise to those who follow us and those who engage with our trivia questions every week. So I'm going to go ahead and read last week's 3 lucky winners. We had Eric Albert, Michael Haney, and Wayne Simon. So thank you so much to you 3. You should be receiving some merchandise soon, whether that be a 7Signal mask or a 7Signal hat. Who knows? So stay tuned. And to the rest of you on the line here today, go ahead and give us a follow and stay tuned for our trivia question as well.
Who wouldn't want a hat like this? Or, now that I have it, boom, the 7Signal face mask. Love it.
Awesome. Perfect. Okay, one more announcement before we move forward here that we're really proud of, really excited about. We have recently been featured in the Gartner 2020 Market Guide for Digital Experience Monitoring. Seven Signal has been recognized as a representative vendor for Mobileye, and we'll go ahead and drop a link in the chat here as well if you care to check out that report. All right, on with the show. A little background about Seven Signal and our history. We were established in 2007 in Helsinki, Finland, and we are now located in lovely Cleveland, Ohio. We are really proud of the 1 billion data points that we're analyzing daily, in addition to the 5 million devices that we're monitoring daily as well. We have over 200 customers, over 30 partners, and 14 patents. Constantly changing and growing in an ever-changing industry here, which goes to show that the technology you see from Seven Signal, you are only going to see from Seven Signal. Moving forward, we are also certified in over 40 countries, and we are GDPR compliant for our EU folks on the line here today, which goes to show that we just take data and privacy very, very seriously for all of our users across the globe. As I said, we are Seven Signal, the leader in wireless experience monitoring, and we're here because the digital experience matters, and it's largely related to Wi-Fi connectivity. So what we're able to do is provide full visibility into the end user experience with an outside-in approach through our platform of Mobileye and Sapphire. We're also completely AP and device agnostic, so those great tools, great technologies that you already have installed on the network, we're completely complementary with as well. So as I said, the digital experience matters, and when it's negatively affected, it's usually bubbled up to one of these top 7 Wi-Fi problems, such as congestion, coverage loss, co-channel and radio interference, roaming issues, and more. And how we're able to detect those top 7 Wi-Fi problems is by running active and passive tests on the edge of the network through that outside-in approach that I mentioned, looking for things like throughput, packet loss, latency and jitter, adapter and driver issues, and more. So to give you a background as to what this means more specifically, if you look at your typical enterprise LAN infrastructure, you've got those great tools, great technologies already installed on the network, giving you really great data, such as your Riverbed, Cisco, Aruba, Appneta, and more. But what Seven Signal does is we pick up where they leave off, providing full visibility into the user experience through Mobileye, living on the edge, giving you that full perspective into what's occurring in your network. Mobileye can also be installed on ultimately any mobile device, such as your laptops, your mobile phones, your Zebra scanners, your workstation on wheels, and more. And additionally, we do have our Sapphire, which are the software-enabled hardware sensors installed up in the rafters, looking down on the network, giving you that service level quality and RF visibility as well. So to give you a little bit more into depth as to what makes us so different, with Mobileye, we give you that full visibility, as I said before, into your external home networks. A lot of people on the line here today are working from home, and those great technologies you had in the office aren't really being used anymore. So you need that perspective and that insight into what's occurring in your home, your multi-tenant apartment, so you can have great connectivity and a great digital experience on your end. As I've said many times here before, work from home is here to stay. A lot of you on the line are working from home, and for me, I'm in the office a couple days a week, and I'm at home a couple days a week. And when I'm at home, it's not just nice to have a Wi-Fi connection, it's mission critical. It's important for all of us to completely stay connected to our work regardless of where we're joining from as well. In the midst of this change in the workplace, we have been doing a give back. Mobileye offer 50 devices for 50 days, and we will go ahead and drop that link here in the chat as well, so you can go ahead and check out what that is. All right, on with the show here. As I mentioned before, we give away a lot of swag and merchandise to those who answer our trivia correctly. So I'm going to launch this poll here that Jim had for us. Are you able to see this, Jim?
Yeah, I can see it. So I've been told my trivia questions are sometimes too easy.
All right, well, we'll see
So I
here.
wanted to pick something a little more difficult today.
Got it. I see a few of you dropping in your answers here. In the UK, is DFS required to use Uni 3 channels indoors? Yes or no? All right, so I'll give our users a little bit more time here. I see some people still dropping in their answers. And I'm going to go ahead and close this poll now. All right, Jim, how did we do today?
The audience got it right. The correct answer is no. You do not have to use DFS in Uni 3 when you have APs operating indoors in the UK. And that's a new ruling, if you're unaware, from Ofcom just this summer. So if you were one of those people that answered yes, you should familiarize yourself with the new rules in the UK.
All right, thank you, Jim, and thank you to all of you who participated. So what I'm going to do next here is I'm going to go pass the controls over to Jim so we can go ahead and get started with this topic today.
Okay, let me move some things out of the way and we will jump in. All right, so I am Jim Vada. I'm the Director of Global Wi-Fi Solutions here at 7Signal. I'm also a CWNE and I have some Cisco certs. And you can follow me on Twitter at Jim Vada. And there's my blog about Wi-Fi and my amateur radio call sign, which is one of those lockdown things I accomplished this summer. But today we're going to talk about DFS. And then I'm going to spend a few minutes talking about what's going to happen with AFC in 6 gigahertz, which serves a similar purpose as DFS. Dynamic frequency selection, and it's used in the 5 gigahertz band. And it's used because there are already licensed incumbents operating in that band that unlicensed users of the band, like Wi-Fi and anybody else that's not using a license to use it, have to stay away from. So those license holders are weather radar, military radar, which can be mobile, could be on an airplane flying over your Wi-Fi network. And there's a lot more. So we often just talk about weather radar, but there's a whole host of users who have priority in the 5 gigahertz band that we have to defer to as Wi-Fi network operators. And those incumbents always have priority. So when they show up, we have to vacate the frequencies that they're using. Just to give you an idea of what this looks like, this is the entire RF the RF spectrum allocation in the United States, determined by the FCC. And each color represents a different use for that band. And you can see in some areas there are, blocks on top of blocks showing multiple users, and there's an awful lot of activity going on in the spectrum. So for Wi-Fi, we get a small portion of the 2.4 gigahertz band we can use, a little bit more in 5 gigahertz that we have to share with incumbents, and then this new 6 gigahertz band, which is much larger, and we'll talk about that as well. But I'm going to mostly focus on the US here, where the FCC is the regulatory agency responsible for making those spectrum sharing rules. But in other countries, there are similar regulators that make the local rules there. So there's Ofcom in the UK, who's responsible for that, the DFS decision we talked about in the trivia question, and others. And although they all have a unique set of rules, there is a trend to try to have global harmonization of those rules. So because it's, it's not good to, if Wi-Fi in the US worked in 2.4 gigahertz and it was 4 gigahertz in Canada and 5 gigahertz in the UK and 6 gigahertz in Russia, it's not good, because then you have to develop new hardware for every single market. It'd be much better commercially if we could all, develop standardized hardware that just has to obey slightly different rules in different regulatory domains. So keep that in mind. But these are the agencies where the spectrum access rules come from that we have to obey. To give you an idea of what the 5 gigahertz band looks like and how much of it is subject to DFS rules, have a look at this chart. So we've got 25 channels we can use in the 5 gigahertz band. And that's the most you can use. And some domains have a subset and not every single channel available. But 2/3 of the band requires DFS. So you really need to know about this, because if you're avoiding DFS channels and if you're not using them, you've sacrificed 2/3 of the available capacity in the 5 gigahertz band that you could be taking advantage of. And if you can't use these channels, co-channel interference is going to be higher because we have fewer channels to reuse. So we want to try to take advantage of this whenever we can. And so it's good to know about DFS and what you need to do to use it safely. So why is it important? Well, it protects those incumbents from interference from our Wi-Fi access points and clients. And we talked about who some of those are. The one that gets a lot of attention is TDWR, Terminal Doppler Weather Radar. That operates on channels 120 through 128, actually. Small correction there. And that is ground-based radar that you'll see at an airport. So if you ever get to fly on an airplane again, when you're taking off and landing, have a look at. You might see something like you see in that photo. And the purpose of these terminal Doppler weather radars is to detect dangerous wind shear that can be very localized on the airport's grounds. And normal weather radar doesn't have the resolution to detect it. So airports, big commercial airports, have their own on-site weather radars. They're very high resolution, and they see wind shear. And wind shear is very dangerous to aircraft taking off and landing. This is an airplane that is experiencing a dangerous amount of wind shear. And if we have an access point that's causing interference to a TDWR, it makes that airport essentially blind to the wind shear on the runways, and makes situations like this potentially occur. So we don't want to interfere with that, of course, because we don't want to be the cause of a horrible airplane disaster. So DFS comes to us in the standard in these two amendments, 802.11d and 802.11h. And you can think of 802.11d, it's easy to remember because the D you can think of standing for domain, even though it's just an arbitrary letter. That's what adds the regulatory domain to an AP's beacon, which tells clients what set of rules they must use while they're connected to that AP. So a client that is moving between APs around the world and moving between regulatory domains can learn from the access point what set of rules it needs to adhere to. 802.11h is where we take the DFS rules from those regulatory bodies and now add them to the standard, add a protocol to the standard so we're always in compliance with those rules. And an access point has to support 802.11h to operate on DFS channels. So one thing to keep in mind is you usually don't have to worry about whether your access points are going to be compliant with the regulatory rules and laws about DFS, because usually, without even asking, an AP vendor is going to sell you access points that are hard-coded for the regulatory domain that you work in. So usually you need to ask if you want to buy access points for Mexico if you're operating in the United States, for instance. That said, and that's a good thing, we just want the AP to have it kind of locked in that it's going to obey the set of rules, and I don't want to have the ability to twist the nerd knob so far that all of a sudden I'm violating federal law. Don't even have that capability. Some APs, though, do allow you to set the regulatory domain. When you first turn it on, it may allow you to decide what country you're operating in, and don't get cute with that. I know some people are tempted, hey, let's use this other regulatory domain where the transmit power limits are actually higher and I can blast away even louder than I could in the US, for example. That's a bad idea because you're violating federal law, and there are consequences for that, so don't do it. So how does the protocol work? There are several phases. The first thing we do is the CAC. That's not call admission control, it's the channel availability check. And what the access point has to do is when it wants to start operating on a DFS channel, it has to observe a 60-second silent period where it's just listening. It's not serving any clients. It's not sending any beacon frames. It's just listening to see if there are any incumbents present on the channel. And if during that period it doesn't detect an incumbent, then it can start up normal operations and beaconing and start servicing clients again. In the EU, to use channels 120 through 128, where those TDWRs are, you have to listen for a 10-minute silent period, which is very, very long. And I think that's one reason those channels are often avoided in Europe. There is a relationship, though, where the AP has essentially all the responsibility for the channel availability check, and the clients just follow the lead of the access point. So as long as an AP is operating on the channel and the client's made sure it's there, it'll start transmitting too. If there's no access point there, the client will not transmit on that channel at all. So assume we've passed the channel availability check. The next thing we do is in-service monitoring. So the access point, not the client, but the access point, while it's operating on the channel, it's still continuously monitoring for incumbents. And if an incumbent is detected, it has to vacate the channel very, very quickly. And so this is where things get interesting, because there are a few different options for what an access point can do. And there are a lot of options for what clients can do in response. But if an access point operating on a DFS channel detects an incumbent present, it can change channels immediately with no warning, just change channels. If that happens, all the associated clients are just, they're essentially orphaned, and they're going to panic roam and maybe find the access point on the new channel or find another AP, but it's going to be very disruptive. The other thing an access point can do is change channels more gracefully using frames called channel switch announcements to inform clients that they're about to change channel, that the access point is about to change channel. So let's look at one of those. So a channel switch announcement can be an action frame sent to the broadcast address, or it can just be an information element appended to a beacon. And it's very, very simple, right? If we look at the contents of the channel switch announcement, we're just saying, hey, we are moving to channel 40. The channel switch count is 0, which means it's going to happen almost immediately. So come join me there. So we've told, the access point has told clients it's moving, but clients get to decide on their own what they will do. And as we know, with a lot of Wi-Fi client behavior, it's kind of a mixed bag. Some clients may see this channel switch announcement and say, you know what, I don't even want to bother with this. I'm going to roam to another access point. I'm tired. I'm not interested in playing this game. I know there's another access point over here. I'll just roam over there. Some clients will see this and say, okay, I'll move to channel 40 and see you there. And then some clients may not respond at all. The channel switch announcement is a foreign language to them, and they may just be, lose their association and panic roam when the channel change occurs because they were unable to interpret this. So all of those are possibilities. Here's an example of a channel switch announcement as a beacon frame information element. What's interesting here is the channel switch count is set to 10. So what that means is after 10 beacon frames, and this will count decrement by 1 every beacon frame, then I'm going to change channels. So with beacon frames every 100 milliseconds or so, we get a full second before we change channels, and 10 beacons, all of which are informing the associated clients about what's about to happen. So we're giving clients a lot of time to see this coming, and a lot of opportunities to make sure they saw the channel switch announcement. Now, while that's occurring, you'll see there's a channel switch mode. What that means is it's a 0 or 1. If it's a 0, it means, okay, while we're in this transition period, the clients can continue transmitting to me the access point. But if the channel switch mode is 1, the clients must go silent. They cannot transmit anymore until the AP has changed channels. But the AP will maintain their association. So if the clients are silenced and they follow the AP to the new channel, their association will be there waiting for them. So this is nice and graceful, but again, how clients respond to this is always a mixed bag. And there's one other format for a channel switch announcement. This is the extended channel switch announcement. This just adds another field, the new operating class, which essentially is useful because it tells you what the channel width will be in on the new channel. So an AP may change channel width, maybe to avoid an incumbent or another access point, to reduce CCI when it changes channels. This just tells the client, hey, look for me on the new, with this new channel width. In this case, Wireshark hasn't decoded that properly, but that's a operating class 3, which would indicate a channel width that the client will be able to interpret. Okay, so after all that has occurred, we enter this period called the non-occupancy period, and this is formalizing the rule that says the access point can't go back to the original DFS channel where an incumbent detection event occurred for 30 minutes. It has to stay away for 30 minutes. Can't even go and check on it. And if it wants to go back to that original DFS channel, we have to observe that 60-second silent period again before we can start transmitting. So just to review the whole flow of what happens. we start with the channel availability check in the silent period before we operate on that DFS channel. Then we go into continuous monitoring and in-service monitoring to see if any incumbents show up. If we have a detection, we might transmit channel switch announcements, and then we go into a non-occupancy period where we can't go back to that channel for at least 30 minutes. So there's a lot of forks in this path, and everyone involved, the APs and clients, can do things differently and make different decisions. And so the devil is in the details as to what is actually happening and what the effect is on your clients and network. Because much of it isn't standardized. The regulatory agencies don't care what channel you go to if once you leave the channel. They just say, you can't be here anymore. What you do after that is up to you. So that leaves it up to the AP vendors, right? And do their auto channel algorithms like RRM play a role? If an AP has a static channel assigned, how will it react? And we see a lot of differences between clients, between AP models and code versions and vendors. There's a lot of possibilities. Some of the things I've seen is an AP on a DFS channel has a DFS hit, goes to a non-DFS channel, and just stays there until I would go in and switch it back. It'll never come back. Or an access point may say, no, I really want to be on that DFS channel. So after the 30-minute non-occupancy period, I'm going to go back to that DFS channel where there was a hit. I'll observe that 60-second silent period and then start operating again. Or maybe it'll move to another DFS channel, which also will necessitate a 60-second silent period to operate on another DFS channel. All right, maybe all the non-DFS channels are already used up, so the AP says, well, there's a free channel in the DFS band. I'll go there at the cost of observing the 60-second silent period. One of the worst case scenarios, though, is the AP could get stuck in a loop and be switching between DFS channels every 30 minutes as that non-occupancy period expires, going through that silent period, dropping all the clients. It can be extremely disruptive. And unfortunately, we've observed that using Sapphire. This is an example of an access point changing channels very, very frequently between DFS channels 64 and looks like 104, and occasionally I think that's 140 up there. See the channel number on the y-axis. And this is an AP that's just really not handling DFS events very, very well. It's just changing extremely frequently. There's observed a silent period every time it changes, and how clients react to the channel changes can be really disruptive. So things can go pretty wrong if DFS events are occurring very frequently. One resource I want to highlight that might help you answer some of those questions about how your access points respond to DFS events is the dfsproject.com. So this is where they've crowdsourced a bunch of packet captures showing exactly the behavior of different access point models and code levels when a DFS event is triggered. So you can go look for your access points there and get a feel for what their behavior might be when DFS events occur. And I also want to highlight how important it is to obey the rules. Again, if your APs come hard-coded to a domain, it's probably not something you really have to worry about, but it's good to be aware of it. Here in the US, the FCC is happy to name and shame the companies they are taking enforcement actions against. They have a page, a public web page where they list all these, and you can read the actions, and it's a lot of them start with federal agents knocking on the door, with questions for the site management. So you don't want that to happen to you. Also, the FCC has paid attention to manufacturers of access points to remind them of their side of the equation in terms of their responsibility to make sure what they're selling is compliant with their rules. This is an enforcement action just from last year with some scary language for access point manufacturers. And unfortunately, even if we do everything right, sometimes things can go wrong. So this is a Cisco field notice. If you've got Cisco, I want to say it is the 3800, yeah, the 2800, 3800, 4800 series APs. Field notice 70577, a code bug, unfortunately, that causes the channel availability check to fail to complete if you're operating on a DFS channel. So not good. And in fact, in this field notice, Cisco says customers who operate APs with the software might be operating in violation of regulatory requirements. They left out the sentence about manufacturers who distribute software that allows this to happen may be violating regulatory requirements too. But something to keep an eye on if you're a Cisco customer. Don't want to cause any trouble with bad software. So a couple of the problems with DFS, from a high level, the major issue here is uncertainty. How do we know if there's an incumbent present? What channels are they on? What if they come and go? We just really have no idea. And what will our APs and clients do? Also, often a very open question. Something that frequently happens with access points are false positives. A DFS event is triggered even though there actually isn't an incumbent present. Usually this is because a Wi-Fi client's own transmission got misidentified as a radar or something else. And there's pressure on access point manufacturers to make their APs really hypersensitive to DFS events. They have to go through a months-long certification process with the FCC before the APs can operate on DFS channels, and they don't want that to get slowed down. They don't want to fail, of course, and have to start over, because that slows how quickly they can bring products to market. And so they have an incentive to make sure they're super sensitive and pass those DFS certification tests. I think that plays into the frequency of false positives too. And then another issue I want to talk about is because a client has to follow the lead of an AP, client can't just go onto a DFS channel and blind probe to see who's out there like it can on non-DFS channels. It has to first hear the transmission of an access point before it can transmit. So it slows down discovery of access points on DFS channels, which can be bad for VoIP in particular. And some VoIP handset manufacturers actually recommend against using DFS channels for that reason. That said, I think it's, again, 2/3 of the capacity of the band is tied up with these DFS rules. So we should try to use as much of these channels as we can. Sometimes I hear that a Wi-Fi administrator, I can't use DFS channels because I'm too close to an airport. And it's become a little crusade of mine when I used to be transiting through airports. Bring up the Wi-Fi scanner and see what they're using, because often, even right there inside the airport, right next to that terminal Doppler weather radar that's just outside the window, they're using DFS channels. So if the airport can use some of them, here's ATL, the busiest airport in the world, there's a good chance you can too. And if you have DFS hits across the whole band, maybe you're experiencing false positives or a code issue or something like that. Maybe it's not incumbents on every single channel that's actually occurring. And just to drive this point home a little bit, the local terminal Doppler weather radar to me is in the Cincinnati airport. This is the spectrum analyzer view of that 5 gigahertz band. And all that TDWR is taking up is that tiny little red sliver of spectrum. The rest of the band is free for access points to use. So I take one channel out of the DFS channels because of that, but there's no reason to avoid the rest of them. Okay, so a couple design considerations. We talked about how important it is to understand and comply with the rules, but one thing you can do to overcome some of the uncertainty is set up an access point, during your design and test each DFS channel for a day or two, maybe a couple access points, so you can do more than one at a time, and see if you have DFS events. And if you have a channel with lots of DFS events, take that one out of your design, but don't, throw out the baby with the bathwater. Test all the channels and see what makes sense. If you're doing, if you've got real-time applications, it's a good idea to know what your access points are going to do when they do have a DFS event. So that's worth testing as well, particularly if you're doing VoIP and you want to try to use DFS channels. Understand how that's going to affect AP discovery for those clients. And then understand how clients, how client capabilities come into the picture here, because some clients don't support DFS channels. That's pretty rare these days for a 5 gigahertz client not to support any DFS channels. What's more common is a client may only support a subset of DFS channels. So it's very common for clients not to support channel 144, but then support every other channel in the band. Sometimes you see clients that don't support 120 through 128. A great reference for this is the website clients.mikealbano.com. This is just a quick screenshot of that website. And you can see for each 5 gigahertz channel, if the clients that were tested support those channels. So you can sort of build what is my universal supported channel list by all of my most important clients. So I only use those channels in my design. Okay, I just want to talk about what we're doing in 6 gigahertz really quickly, because it's something similar to DFS. In the US, we've got 1200 megahertz of spectrum that unlicensed users use, like Wi-Fi, but just like 5 gigahertz, there are existing incumbents there. One of the most common ones are point-to-point microwave links, like you see in that photo of the big dish antennas. Some of those are using the 6 gigahertz band for fixed point-to-point links for data transfer, and they're licensed and they're incumbents, and we have to avoid them. But we're doing this, we're avoiding incumbents in a totally different way, using a service called Automated Frequency Control, or AFC. And with this, our access points don't do any incumbent detection. We're actually using a centralized database where the access point or controller is reaching out and asking, what channels can I use? Which is kind of a really neat approach. It's new to Wi-Fi in terms of stuff that's actually made it to market, but these kind of systems have existed before. So with the TV white space band, 802.11 AF, not 802.3 AF, 802.11 AF developed a similar system, and the one that's also coming to market at the same time as Wi-Fi 6E, CBRS, the SAS, the Spectrum Access System, works very, very similarly to what we're doing with AFC and Wi-Fi. So there are some, there is some precedence here for AFC. Okay, so the good news is most 6 gigahertz most 6 gigahertz APs and clients can use the full band without even worrying about AFC. The FCC in the US has decided that as long as an access point meets certain requirements that we classify as low power indoors, then AFC is off the table. So that means the access point can only operate indoors. It can't transmit at more than 18 dBm in a 20 megahertz channel width, which is perfectly fine. And that maximum may increase in the future. And it can't have external antennas. So that covers an awful lot of APs. Your sort of bread and butter indoor omnidirectional AP can fit within these requirements just fine. It's really just the APs that go outside or need to use a higher transmit power that have to obey these AFC rules. And these are called standard power APs. They can go up to 36 dBm, which is 4 watts, which is great if for outdoor, particularly point-to-point, point-to-multipoint links. And then just like DFS, clients follow the lead of access points for AFC. So how does AFC work? Well, it's very, very different from DFS. The controller or the access points reach out over the internet to this AFC service when they're coming online and say, hey, what channels can I use? And the AFC service is where all the heavy lifting occurs. What it's going to do is query the FCC's license database and say, okay, what incumbents are present in this area where this access point wants to operate? Because the access point also sent its location to the AFC. And the FCC database, which is a publicly searchable database, has all the incumbents, and it shows where they are, their location, the frequency, transmit power, antenna characteristics, and it gives all that raw material to the AFC, which takes it and does RF modeling to estimate where the incumbents are and where the interference zones are for the area those access points want to operate. It does that model, determines what channels the APs can use and what they can't, and then it responds to the controller, which may be acting as a proxy for the access points, and says, here are the channels that are free. Go ahead and use those. There may be more than one AFC service. I think there will be. With CBRS and the SAS, there are, I think, 5 or 6 different SAS operators. I think we'll see more than one AFC service. So far, the only company that's announced one is Federated Wireless. But of course, the AP vendors have an incentive to perhaps start their own AFC or do so in a conglomerate way. So we'll stay tuned and see what happens. But just to see the flow again, the AP or WLC checks in with AFC every day to see what channels can be used. The AFC does the ULS lookup, RF modeling, decides what channels are free and what transmit power is available to avoid interference, sends that back down to the WLAN, and then it's still up to you, the Wi-Fi administrator, or a RRM algorithm to decide what channel that access point is going to use from the list of available channels. So there's a lot to be happy about here. First, we've got certainty. We can query the database and see what channels can I use, where are the incumbents, and know for sure what's free and what isn't. No more false positives from access points having to do incumbent detection while they're also servicing clients, and all the problems that go into that. We don't have a disruptive silent period. And the majority of the time, we don't even have to worry about it because again, our bread and butter indoor omnidirectional APs aren't even subject to AFC rules unless we need a significantly higher power. So lots to like about AFC compared to DFS. And with that, Kelsey, maybe we have a minute or two for some questions.
Thank you, Jim. I see a lot of you have put some really great questions into the chat here, so we'll try to get to at least one of them. We had a question from Pete, and he would like to know, how does the AP pick a new channel after it detects a DFS contention/incumbent?
Good question. And that's where you'd want to go to the dfsproject.com, because what you'd see is different behavior for different access point models. And it can be very varied. So check and see if your access points are listed there, and if not, check with the AP vendor on to see if they have documentation that might explain that.
All right, thank you, Jim. And let's do one last question here from Forrest. They'd like to know, do most clients implement DFS like small handheld scanners or laptops, or is it just the APs that switch out of Uni 2?
When DFS first came out, this is a little bit of kind of minutia, but there were some clients that did DFS detection too. But now it's entirely the responsibility of the access point, and the clients just follow their lead.
All right, thank you, Jim, and thank you to all of you for placing those questions in there. Unfortunately, that's all we have time for today. Thank you all for joining us today and taking 45 minutes out of your workday. And thank you to Jim for joining us again for the part 2 of this great topic. So we're really happy that you were able to join us.
Thanks, guys. Thanks, Kelsey.
Thanks, Jim. Thanks, everyone. Have a great rest of your day. Bye.